Okay, this is the video on bearings, which is page 14. This is a new section that was introduced when they changed the syllabus to applications for math studies. It is maybe something that you did before, like in middle school. Basically, it's how to use north, east, west, south compass directions to define a direction on a map. And there's two ways they can do this. One is using, and this is the one that would most often appear in IB exams. They give you a 3-digit number, and sometimes the first one or two numbers is 0, depending on if it's a number smaller than 100 or smaller than 10. They'll give you a 3-digit number from 0 to 360 degrees, defining which direction you're going to go. So the only hard part is, what is the 0 degree? Where do they mark that? And they mark that in north. So like the north direction is defined as 0, 0, 0 degrees. And so east would be 90 because they go in a clockwise direction. Okay, so 90 degrees would be east, 180 degrees would be south, and 270 degrees would be west, right? And then you could have any increment in between. So if I said 0, 4, 5 degrees, that would be 45 degrees from north. It would be like that. It would be like northeast, right? The other way they could do it, which is less common, is this notation here, which is north 20 degrees east, which first they're going to define if the principal direction is north or south. And once they define that, then they tell you, okay, are we going to go a little bit to the left, or are we going to go a little bit to the right? And the way they define left and right is east. So like, for example, if we have north 20 degrees east, that would be 20 degrees east of north. It would be slightly to the right of north, right? If we had north 55 degrees west, then that would start at north, but it would go 55 degrees toward the left because that's west. South 36 degrees east, that would start out south, but it would go a little bit to the east of that, right? And finally, south 67 degrees west, that would be starting with south, but then go toward the west, okay? So it gives you this sample angle A defined either in the 3-digit method or using the north, south, east, west method. 240 degrees would be measured from north clockwise. That would be 240. And then, of course, south 60 degrees west, you'd start out with south, and then you go 60 degrees to the left of that because that would be west. And you can see that those end up in the exact same place, right? 240 degrees, maybe you didn't know that that was over here in this quadrant, but if you go 270 degrees, that would be west. If you go 180, that would be south, so it's halfway in between those two, right? Okay? All right, so let's take a look at the first problem here. The first problem says, a boat travels on a bearing of north 36 degrees west for 25 kilometers. How many miles north has the boat traveled? Okay. So in this case, they're giving it using the north, south, east, west notation. So remember, north 36 degrees west means start out north and then go a little bit to the left of that toward west. So that would be this angle here. How many degrees to the left did you go? 36 degrees. Okay, so it's kind of like in that direction. This is north. For 25 kilometers. So we go 25 kilometers. And then it says, how many miles north has the boat traveled? How many miles west has the boat traveled? If you make a right triangle out of this slanted line here, you can see how many miles north. It would be this segment here. And you can see how many miles west. It would be this segment here. Okay? And we are going to use SOHCAHTOA because this is a right triangle, right? So do we know something about this angle or this angle? Well, this angle here, you can see that it is complementary to the 36 degree angle, right? This is a right angle, so that means 36 plus this unknown angle is going to add up to 90. 90 minus 36, it turns out, is, I think, 54. So this is actually 54 degrees. So what we can do is we could do SOHCAHTOA with 54 degrees. I'm going to erase some stuff here to make it a little bit less busy. So 54 degrees would be this angle here. And then this is a right triangle, and we know that this hypotenuse is 25 because that's how far the boat traveled. So what they want to know is they want to know this component and they want to know this component. And the way we can find that out is using sine, cosine, tangent, right? So let's try to find x first. So x appears to be the adjacent of 54 degrees, and then we know the hypotenuse. So adjacent hypotenuse, wouldn't that be cosine? So we can find the x value by saying, okay, the cosine of 54 degrees is equal to x over 25. And the cosine of 54 degrees, let's find that out on the calculator. Let's first put the mode as degrees. And then we quit out of that. And then we say, oops, we quit out of that. And then we say 25, cosine of 54 degrees is .588. So it's 0.588 equals x divided by 25. So x is equal to 25 times 0.588. So let me multiply that times 25. And the answer is 14.7. So the x value is 14.7. That would answer how many miles west. Right? So how many miles north? So we could use the opposite divided by the hypotenuse for that. So it would be sine, right? So I'm going to put sine of 54 degrees equals y divided by 25. And we know that sine of 54 is sine 54. It's going to be 0.809. So 0.809 equals y divided by 25. So y is equal to 25 times 0.809, which is equal to 20.2. Okay, 20.2. So we know that the answer to part A is 20.2 because that's the y component, which is going north. So they said how many miles north? We found the opposite side of the right triangle. How many miles west? We found the adjacent part of the right triangle. And the only part of this that is different than the previous pages you did was they gave the direction in this format here, and they're using north, east, west, south. Number 7. A boat is due south of a lighthouse and sails on a bearing of 292 degrees for 51 kilometers until it is due west of the lighthouse. How far away is it from the lighthouse now? Okay, so here they're using the 3-digit method of giving us the bearing. So basically what that does is we start with 0 degrees at north, and then we go around in a circle until we get to 292 degrees. Remember, west would be 270 degrees, so 292 degrees, you've gone so far around that you are pointing almost north again. Okay, so this is 292 degrees, and then we're going to go in this direction for 51 kilometers. And then we're going to say how far away until it is due west of the lighthouse. A boat is due south of a lighthouse and sails on a bearing for 51 degrees until it is due west of the lighthouse. Oh, are we talking about the same lighthouse as before? No. Okay, I get it. I was a little bit confused there for a second. Okay, so the boat starts, here's the lighthouse, and here's the original position of the boat. It's due south, right? The boat is due south, which means it's perfectly south of the lighthouse. We went on a bearing of 292 degrees, which is kind of like to the left of the lighthouse, for 51 kilometers until it is due west. And so we stopped when it made a perfectly horizontal line here with the lighthouse. So we've actually drawn a triangle, haven't we? I'm going to redraw the triangle here. So we know that there's a right angle here because it's perfectly west. This is the lighthouse, and this is the new position of the boat. So I'm going to put boat dash, and the old position of the boat here is B without the slash. And we know that this is 292 degrees, so can we figure out this angle here, which is the remainder of the 360 degrees? It would be 360 degrees minus 292, which would be 68 degrees, right? So this is 68 degrees. And then we have, we want to find out how far away it is from the lighthouse. Now, that would be this quantity here. And so, and we know that it went 51, so we know the hypotenuse. We just don't know this one, but we don't really care, right? Because we can figure this out using SOHCAHTOA and two sides only. So let's set this up. If we're going to use x in 51, x is the opposite to 68 degrees. So we're going to do opposite over hypotenuse, which is sine. So we'll do sine of 68 degrees equals x over 51. And the sine of 68 degrees is, we'll do sine 68, which is 0.927. So I'm going to write that down. 0.927 equals x over 51. And then I'm going to multiply the 51 over to the 0.927. So I'll get x equals 51 times 0.927. So I'm going to multiply this times 51 to get the distance of x. And it turns out it's 47.3. Okay, so the answer is it's 47.3 kilometers due west of the lighthouse. So this is going to be 47.3. Okay, and that's it for page 14.